They're in several types. So we'll do them in form of examples. So example numbers will demarcate the types. Example 1, solve for x. A, 2x plus 3 is less than 12. These are some of the easiest inequalities that we find in notes and not in exams. But they help us understand critical things that may need that may be needed in hard stuffs. So the idea here is you solve for x, so you can take this to the other side. We'll have 2x less than 12 minus 3, giving us 2x less than 9. And then divide by 2, divide by 2. So x is less than 9 over 2. If you want, you can write as a solution set where you infinite all the way up to 9 over 2, not included because we only have less there. A follow-up example would be negative 4x plus 7 greater or equal to 18. So first again, you take this to the other side. So you have negative 4x greater or equal to 18 minus 7. That is negative 4x greater or equal to 11. Divide by negative 4, divide by negative 4, you get x less or equal to negative 11 over 4. So you note that every division or multiplication by a negative changes the inequality. If it was greater or equal to, it becomes less or equal to. If it was greater, it becomes less. Now, after you get this, then you have questions like negative 3 less than 4x minus 2 less than 12. Let me say less or equal to 12 there. Again, here we have two separate equations, but if you want, we can be solving this as one, where you take this to the other side. At the same time, you take this to the other side. You can do that. So you have negative 3 plus 2 less than 4x less or equal to 12 plus 2. So it becomes an easy thing that way than separating them. So we get negative 1 less than 4x less or equal to 14. And then divide by 4, divide by 4, divide by 4. So we get negative 1 over 4 less than x less or equal to 7 over 2. Even that way, so the idea here is you should be able, if you wanted, you would have separated this, or you say negative 3 less than 4x minus 2 and 4x minus 2 less or equal to 12. Solve them separately, so you bring negative 3 plus 2 less than 4x giving us -1 less than 4x, divide by 4, divide by 4. So we get -1/4 less than x. And then go the other side and say, 4x less or equal to 12 plus 2. So you get 4x less or equal to 14, divide by 4, divide by 4. X less or equal to 7/2. And then you get the intersection between the two. So the intersection set here would be, we are saying x is less, -1/4 is less than x. But this very x is less or equal to 7/2. This becomes our solution set, which is the same as what we have there. So for easy questions like these, there's no need of separating them. If we do D, I'm bringing something like, let's see, 20 greater or equal to 3/4x plus 1 greater than greater than 2. So it's possible to have the inequalities. Okay, if you want, you don't change anything. Okay, just take one the other side. So you have 20 minus 1 must get or equal to 3/4x greater than 2 minus 1. So that we get 19 greater or equal to 3/4x greater than 1. Cross multiply everything by 4. We'll get 19 by 4. That's the that's 6 here. And then 7.
Sir.
Yes.
Sir.
Hello.
Oh, to ask one say. On the sort of like
I don't know whose network is tripping.
Your line, I don't know, your line is breaking. Oh, I was asking like on the solution set on C,
Yeah.
no need
Yes.
to put in open or closed brackets there. It's just like that.
If you want, you can write this as -1/4, 7/2. It's the same thing. Okay, so here we have greater or equal to 3x greater than 4. And then divide by 3, divide by 3, divide by 3. So we'll get 76/3 greater or equal to x greater than 4/3. And you can leave it like that. But if you want to write it as an interval, you start from 4/3 to 76/3. Because intervals are not reversed. For intervals, if you have a comma b, it means that a is less than b. and not the other way. Okay, so now this is type 1 where the denominators, if there are any, are constants. We go to example 2. Still solve for x. This time around we have x minus 1 over x plus 2 less or equal to 3. We have a variable in the denominator. So solving for this, there's no point where we should cross multiply. It's not allowed. Because you've seen that when here we made the note that whenever we multiply or divide by a negative, whenever we multiply or divide by a negative, the inequality will change. So if we multiply or divide by a variable, which we don't know whether it is positive or negative, we have issues on whether we should change the inequality or not. So that's the reason why we don't do that. So that here, the common denominator will be x plus 2, and then x minus 1 minus 3, x plus 2 less or equal to 0, giving us x minus 1 minus 3x minus 6 over x plus 2 less or equal to 0, giving us minus 2x minus 7 over x plus 2 less or equal to 0. Now that we have a fraction of a variable up and a variable down, we get the critical values. Critical values, which is negative 2x minus 7 is equal to 0, giving us negative 2x is equal to 7, divide by negative 2, divide by negative 2. So x is equal to negative 7 over 2. Then x plus 2 is equal to 0, x is equal to negative 2. So we have this, we also have this. These are called critical values, and we need them for testing, table testing, where we put the smallest is negative 7 over 2, and then negative 2. There's no whole number in between here. No, there is. So in between here, there's negative 3, and then 0, and then negative 5. Then you pick negative 2x minus 7, pick x plus 2, pick negative 2x minus 7 over x plus 2. And then when x is negative 5, this will be positive, negative, negative, and you divide the signs there. When x is negative 3, this will be negative, this will be negative, so you get positive. Then we have a negative there, positive, negative. So we take note that whenever.
Sir, can you repeat on the sign?
Okay. On the sign, or on the signs, meaning the table, is it?
Yes, yes, yes.
Okay. So after you pick a number less than that and one in between these two, then the other one bigger than negative 2, you substitute where there is x, you are taking these numbers that you have picked in each interval. These numbers here. So for the first one, you have -2 multiplied by -5 minus 7. So you get 10 minus 7, which is 3. 3 is positive. Your interest is just for the positive there. Then also get -5 plus 2, you get -3. Your interest is the sign. And then you multiply positive times and negative to get the negative, which is down here. In other words, Kai, we know that when you're dividing signs, the same as multiplying. And then go to -3. You have -2 by -3 minus 7. That is 6 minus 7, which is -1. So just pick the negative and take there. And then -3 plus 2, we get -1 again. When you multiply them, we have positive. If you take 0, you get negative there and then positive. If you multiply, you get negative. Then now we are putting a note here to say whenever there is less or equal to or less, pick the negative sign. Pick the negative intervals. And whenever there is positive or equal to, greater or equal to or greater, pick the positive intervals. That's what you do there. Meaning, in our case, we have less or equal to, so we'll pick the negative. So our solution set is going to be from -infinity all the way up to -7/2. Now we go back and check which part of this fraction gave us -7/2. It's a numerator. So we include this one because we have less or equal to. Union, start from -2 all the way up to +infinity. Which part of the fraction gave us -2? The denominator. Since we don't allow the denominator to be 0, we still want to include -2. So that you should never forget, we should say.
Can you just please repeat that explanation?
Okay, so that you never forget, we should say when you have less or equal to or greater or equal to, include the critical values for the numerator. And denote the denominator. Since anything divided by 0 is undefined. So because -2 is on the denominator, we don't include it. Because if you include it, what will happen is that when you use that -2, you get -2 plus 2. It will be 0. So what will be a number on top divided by 0? Undefined. So you take note of that.
Let's multiply when the denominator is like x plus 3. Then when it's a number, that's when you multiply. You cross multiply.
You only cross multiply. You only cross multiply if the sign is known. And most the sign is known for constants.
Okay, good.
Mhm. Okay, B, so this was A, this was A. In this type, we bring B -2 less or equal to x plus 1 over 3x minus 2 less than 4. This looks like what we had here on C. The only challenge here is that there's no cross multiplication, so you can't do it at the same time. So what we'll do is we'll take the second option of C, where we said you can also do this. So we'll have to separate them. So we'll have -2 less or equal to x plus 1 over 3x minus 2. You use and x plus 1 over 3x minus 2 is less than 4. So that you now solve them separately and then get the intersection. This means that solving here, we are free for as long as we don't cross multiply. We can have it in this form. This is the same as over 1. So 3x minus 2 is in the denominator. Then we have -2, 3x minus 2 minus x plus 1 less or equal to 0. Notice how I bring in the brackets there to avoid misusing the negative. So I have -6x plus 4 minus x minus 1 over 3x minus 2 less or equal to 0. This is -7x plus 3 over 3x minus 2 less or equal to 0. Then get the critical values. -7x plus 3 is equal to 0, giving us x is 3 over 7. Also 3x minus 2 is equal to 0, giving us x is 2 over 3. Okay, then we need a table, testing table here. So which number is smaller than the other here? 2 over 3 should be smaller than 3 over 7. Let's check if it's true. 3 over 7 is 0.4. Then 2 over 3 is 0.6. So it's the other way around. Okay. So 3 over 7, 3 over 7, 2 over 3. So to find a number in between them, the easiest will be adding these two. That is, which number can go down? 21. And then 7 there, 3. 9 plus 3 there, 7. 14. So we get 14 plus 9. That's 14 plus 6, 20, so 23.
23.
Over
23.
20. Okay, then we divide it by half, which is the same, I mean by 2, which is the same as multiplying it by half, so that we get 23 over 42. So 23 over 42. It's a middle number. And then now we are free. We can use 1 here and 0 the other side. And then bring our negative 7x plus 3, our 3x minus 2. You can copy x, the fraction. You can call it n name. And then we test. So we substitute. So we substitute 0. We'll get a positive here, negative, negative. So that here we must have a positive and then negative here. Let's confirm the negative, which is at the last. If you take 1 there, we'll get negative, positive, so we'll have a negative indeed. Meaning that the positive in between here will be a thing, because normally the signs alternate unless otherwise. So it's important to test also. So negative 7, 23 over 42 plus 3. 7 here 1, 7 here 6. So we get negative 23 over 6 plus 3 over 1. 6 can be down. So negative 23 plus 18. It's a negative number. Then 3 multiplied by 23 over 42 minus 2. This is 3 here 1, 3 here goes how many times? 1 there, 4, 14. So we get 14 down, and then 23 minus 28. So it's a negative. When you multiply the two negatives, we get positive. So after doing that, then we get our solution set now. We are coming from the negative inequality. That's what equal to.
And how do we get positive? The previous one you are explaining.
This when you multiply these two. So you always get the signs that you obtain in here to give us the last one. Where you get this and take in each of these. Is it okay?
Yes, so we have to replace x with those numbers on top.
Yes, these numbers that you have circled on top here.
Okay.
And how do you pick those numbers that you have circled on top? You choose per interval. You're free to choose a number for those that lies within that interval. So since we have less or equal to, we'll have our solution set to be negative infinite all the way up to 3 over 7. And check where it is coming from the numerator. So we include it, union 2 over 3 to infinity. Now we're not yet done. When you get this, you call it solution set 1. You go back to the other piece, x plus 1 over 3x minus 2 minus 4 less than 0 over 1, and get it x plus 1 minus 4, 3x minus 2 less than 0. So you get x plus 1 minus 12x plus 8 over 3x minus 2 less than 0. And then you get negative 11 plus 9 over 3x minus 2. Critical values will be negative 11x plus 9 is 0, giving us negative 11x is equal to negative 9. X is 9 over 11. And then 3x minus 2 is 0. X is 2 over 3. This means that, again, you check which one is bigger here. So 11 over 9 over 2, I mean 9 over 11 should be smaller than the other guy. That would be 0 point. If you do that, that's that should be 8. And then the other one, 0.8 also. Tricky. Okay, let's use another way of knowing which one is bigger than the other. Let's use 2 on both numbers. Negative 11 by 2 plus 9 will give us negative 22 plus 9, which is negative negative 12. Can this work? 3 by 2 minus 2 will give us 5. Okay, I'm not so sure if this can work. So what we do is we suspend, because we only have, so I wanted to be quick because we only have 2 minutes and we need that solution and this solution to get the intersection. So we'll keep this page. So what we'll keep is this solution here. And then we come and do this other piece in the next class. So once you log out, click the log back so that we can do the other piece and then intersect with this one. So when we come back, I'll ask for these pieces. Let me just take a quick. Okay, I've kept it. Okay, so let's log out and get back.